Hey guys, Weekend Modder here, and today I would like to walk through a CR4 Muffin install on this Trinity motherboard. So based on the pin header alignment here, we know that this is a Trinity console that I've gone ahead and decased, and wanted to just highlight the tools that I'll be using to do this. So the possible set of tools that could be used are some form of read-write NAND device. So here I've got a NANDX, and then here is a JR programmer. Either one of these devices could be used interchangeably for this tutorial. And then on this side I have a glitch chip. So this is a Matrix V1, and this is a Cool Runner Rev C. Again, either one of these could be used. Today, and according to my own personal preference, I am going to stick with the Matrix V1 and the NANDX. The Rev C that I mentioned is interchangeable in this function, but it does have a slightly different pin layout, meaning like A is not A and B is not B. It's not all exactly the same. So at minimum, I will post kind of a translation document between the two of which points go to where, but the video, this specific one, will be in detailed in regards to using a Matrix V1, a NANDX, both of which are available at my store, store.weekendmodder.com, and we'll use these to perform the CR4 Muffin install on this Trinity console. So I'm going to go ahead and set these out of the way and pull the console back over, and we'll get started here in just a second. Alright, so again, this is a Trinity motherboard. You can see here that it's got a 4 gig add-on module. So step number one is going to be to read the NAND. So what I'll do first here is use my handy little fiberglass scratch pin and just run that over the top coating of the NAND header points. And that is primarily due to just remove the little bit of coating that's on the top of them so that solder can stick well. So you can see now the points are a fair bit shinier than they were, and solder will adhere much more freely to them. Now we're going to pull out some Flux Paste. This is Amtech Flux Paste, so I'll throw a link to this in the video description as well. You can pick it up on eBay real cheap. There's also an Amazon option. You know, no big problems there. So just putting a nice healthy little coating over the two headers here that we're going to use. And next up, I'm using some 6040 10 lead solder. This is Kester brand. It's like 0.68 millimeter, I think. It's relatively thin, and it is rosin core. That's important to note, as I feel it provides a better working experience. And then I'm using a soldering iron. The particular iron that I use is a Hakko FX 8880D or 888D, and I operate it at 470 degrees Celsius. So just run my iron over the flux just to kind of melt it out a little bit here. And the wires that we're going to install will be done according to the official Team X diagram for the NANDX. But essentially what I'm doing now is just pre-tinning those spots. This last spot is not uncommon to require heat held on it for a bit longer due to the fact that it's a ground plane and it can dissipate a bit more heat. The next spots that I'll be doing are the final two blue and green wires for the NANDX wiring. But we're also going to go ahead and hit the 3-volt location, which that's going to be the power for our glitch chip, and the ground location. And I'll overlay a diagram here to indicate what it is that I'm wiring up. But essentially, we're just pre-tinning all those locations. So now again, according to that color diagram, we're just going to install. So we're going to go black wire, And just in case anybody's curious, this is a standard set of Nandex wires that have just had a heat shrink tubing with a little bit of a leg of a resistor soldered onto them, so it's a little bit more sturdy than just the stranded wire itself. So in the next position, we go brown. In the next position, we go red. I wonder if you guys are getting, there we go. Hopefully that resolved any echo that might have been going on. Next position is orange here. And this ball, I can see in the camera it doesn't look so great, but it's not bridged at all here. If we turn it in this way, you can see clearly. And then finally, yellow for ground. And then blue on the left side. And green on the right side. Alright, and again, this is going to be our power point, the next one down here. So we are intentionally leaving that in here. So there's our 3V 3 and our ground for the glitch chip later on. Alright, so what we're going to want to do is back the camera up here just a second. We'll slide the console over. We'll grab standby power and connect it. Note that I'm not turning the console on at all. I'm removing the CR programming cable from the glitch chip. I'm just gonna, or excuse me, from the Nandex. I'm gonna plug in my Nandex. I'm going to connect that to the connection we just soldered, and I'm gonna let that set here. Now we'll bring up JRunner. You get a glance at my desktop background there. So here's JRunner. And the first thing we can do is hit this little circle. We get a valid flash config, so we know we're good there. We can go ahead and read NAND, get this input name pop up, we just say OK, and we begin reading the NAND. Now while this is going on, I oftentimes like to perform the modification on the LED ring of light, but for the video's sake we'll probably just speed this up until it's close to finished with the second read. One thing we could do, or I could do here, is go ahead and pull up JRunner. So these are going to be the points as this first NAND read is wrapping up that we're going to be hitting for this Muffin style install. So as this NAND read starts to draw to a close here, you'll notice that in the first NAND read I didn't have any indications of bad blocks here. If you do, that's totally fine. What you want to see is that the bad blocks are indicated consistent. So if you see a bad block reading in the NAND dump 1, you should see the same bad block indicated in NAND dump 2. Then you should get a nice little scrolling message about how bad blocks were remapped. And at the end, as long as you get that NANDs are the same option, then the bad blocks are irrelevant and you're good to go. So even if you have bad blocks, if at the end of your couple of reads you get your NANDs are the same, you're good to proceed with the next steps. So I'm going to go ahead and disconnect my NANDX. I'm leaving the wires installed here, obviously. I'm going to go ahead and disconnect my standby power. And then actually as the next steps, we're going to go ahead and prepare the glitch chip. So again, as I mentioned, we're using the Matrix V1 here. And I also had an image up near the JRunner image here. So if I can go back to that, the JRunner image here, what we're doing is this installation type. So you'll notice that I can't seem to scroll in. Zoom. There we go. Zoom. So we have VCC, this is 3 volt 3. We have ground, which we already identified. We have RST, that's on a cool runner Rev C, that's point D. We have post, which on a Rev C is point C. We have nothing indicated for C here. This is actually standby click, or STBY underscore CLK, which is on a Rev C point B. D is left empty. E is used for the DB2G3, which is the point first identified in like JTAG and CR4 installs. If you have a glitch chip that does have this crystal present here, this crystal will not be used with the installation type that we have. So you would want to remove this resistor here, this 0 ohm resistor that causes the bridge to drive the crystal. If your Matrix V1 has a crystal, remove this bridge and make sure that it is unbridged. It should look like 2 little empty pads, and that is what you would want to do for here. If we look at my glitch chip, you can see that the glitch chip has a spot for a crystal, but there is not one present. So based on the fact that there is no crystal present, we don't have to worry about removing any resistor. Additionally, you might notice that the package here is a little smaller. It's simply just a change in form factor for cost saving sort of stuff. It makes no functional difference to the operation of the chip. So in the image, the reference image, so in the reference image here, you have a full-size X264A style package, and on the one that I'm operating on, it's a bit smaller here, but that's not a problem at all. So again, per the diagram, we just want to go ahead and pre-tin up kind of our spots. I like to do this before I insert it. So you might have noticed that little wire indicating to the slim side on these, that one to be left alone. We're going to be doing VCC, so just 3 volt 3, ground. We're going to do pad A, RST, pad B, post. We are going to do pad C, CLK, and then we're going to do pad E, the DBG2, whatever that point was. So D and F are left unused in this installation method. Additionally, I've gone ahead and just stuck some double-sided foam tape to the bottom of the glitch chip, and we'll go ahead and place that in the console. So console comes in, and for this glitch chip installation point, I like to put it right in the same spot where we did the aces, right about here. The one key point that you're going to want to make sure that you pay attention to is that in here, see if we can get her to focus. See this little pair of resistors here, we are actually going to be soldering to the top side of the leftmost resistor there, right there. So we don't want to cover those. We want to make sure that that's still accessible, so we can hit that top left resistor side there. So position your chip with that in mind. I'll go ahead and peel off the adhesive backing and go ahead and place that bad boy right about there. Works for me. Now, for wiring, it's not significantly important, I have found, on the Muffin install to use like the Kynar wire versus regular wire. So really, use whatever you like. What I'm going to do is just use some leftover wire bits that I have. So this happens to be yellow. It really makes no difference as long as you run them to the right spot. So I'm going to connect that to my VCC point. That is actually going to run over to the power point there. So I just like to measure it out, cut it short, and then what I'll do is I'll strip just a tiny bit off the end here. So I have a little bit of exposed wire. Now I'll take my soldering iron and actually just kind of pre-tin that. And that's because the wire is like braided. They call it stranded wire. And it likes to separate unless it's kind of had a little bath of solder of its own. So now we'll go ahead and hit our 3-volt 3-point and insert that exposed bit of end wire, making a solid connection for 3-volt 3. And it's kind of rinse and repeat on the ground wire, just to make things in the video a little more differentiated so people don't have to be confused. I'll use a different color, although not super relevant. You could totally use more of the same color wire. I'm going to go ahead and just use some blue that I have here. So got our blue wire there, and that was the other spot that we pre-tinned and we had to before. So we're going to run to about there, snip our wire, and repeat the process. So expose just a tiny bit and pre-tin the wire. In this particular case, it looks like I have gotten a little bit more exposed than I really want to. So I'm actually going to come back after having tinned it and shorten that up a little bit. Alright, now I'm ready to go ahead and install that to my ground point. And there we go. Now we have power and ground supplied to the glitch chip. Now the next point, the point A, which again, if we pop back to our reference image, point A would be RST. I'm going to skip that one and save it for last because it is the most sensitive one, I guess we'll say. Especially for a newbie, it could be an easy one to mess up here. So we're going to go to point B, which we saw as post, and B post actually routes to the underside of the motherboard here. So let me see if I can find another color wire. I think I'm going to be stuck using some more yellow, but that's okay. Alright, so I'm going to go ahead and wire this one in from the opposite direction. And that is because I'm actually going to run it over to this hole and under and through. So I'm going to go ahead and take out my front ring of light board, which I've already removed the screws for. I'm going to gently lift up on the motherboard, remove it from its casing, and see here that now my hole is open. I can insert my wire, pass her down through, pull it from the other side a little taut, and the post point is actually the same as every Trinity install that you would do. So the way I like to think about it is over one, up one, over one. So it's that second low point here. We'll post a reference image for that as well. So I like to just pull it taut, get an idea for where my length needs to be, get that trimmed up. And yes, wiring these size does seem to be, a factor, so you don't want to go crazy and have tons of additional exposed wire. But super precise length is not required. So there we go. Is our wire tinned, and once again, we've got a little bit more exposed there than we really like. So I'm just gonna trim it up just by a hair. There we go. All right, I'm gonna hit my spot with just a teeniest bit of flux. Go ahead and pre-tin that bad boy. All right. And then for my money, the way to do this is like this. Place her on there. All right, and we've got some spots bridged here pretty bad. So we just want to only have that one anchor point. And if you see, when we get this focused in, there we go. I will use my tweezers. I'm just gonna, yeah. So you can see we're clearly not bridging any other points here. There we go. That looks good to me. For points like this, what I like to do, is, since I'm not going to come back to the back side of the motherboard, so I just use a little cotton round. I've got some isopropyl alcohol. I just kind of rub that out and clean up that flux. And I'm being fairly cautious with the point itself, right? I don't want to rip it out or anything. So at the end, we're left with a nice clean little point. And then, much to the chagrin of my competitors, I guess, they don't like that I use some hot glue to kind of provide an anchor point. So if that ever gets tugged on, the glue will be able to resist the pull. Notice how I don't glue over the point. I just glue back from it so that if it ever gets pulled on, it won't yank off and ruin that point. It's really easy if you just take that same cotton soaked in isopropyl alcohol, kind of drown the hot glue. If you need to remove it, it'll just pry right off, no problems. So there's our point B, our post point. And then the next one we're going to do is point C, which is our standby click, STBY_CLK. Now what most tutorials will advise you to do is use this point up here, which is actually really difficult to pinpoint. This second pad, or the left side of this resistor here. I can absolutely solder that, but with the idea of people doing their kind of first time soldering following this tutorial, there is an alternate point which works really well, which we can use in this case. It does happen to be on the underside of the motherboard. So what we're going to do is find a little bit of wire that's maybe, it doesn't have to be super long, 3-4 inches, something like that. And we'll run that through to the underside, and I'll help you identify what that point is. So we're just going to go ahead and anchor that here, point C. And then feed that through the hole right there near the south bridge and just pull her through. So we just run right through the hole there. Now, the point that we're looking for here, when we come out of that hole, the way I like to do is go up to this one and then look left near the NAND header here. So we're looking for FT, let's see, FT, yeah, up and then left all the way to over here. So FT3 in 2, FT3 in 2. So right there with the little circle around it, FT3 in 2. that little guy right there. So we can bring our wire around, get our length, right? Trim it, give it just a little bit extra, and take this bad boy, trim her up just a little bit. Alright, you get a little bit too much exposed wire there, like we have seen before. So what I'll do is I'll use my iron, tin it up, and then trim it after it's tinned. So there, it's got a nice little coating on it, and we'll trim it back so that it's just a small little bit of exposed. And make sure you hang on to that little bit that you trim off, not long term, but simply making sure that it doesn't just get left on your motherboard, because that could short something out down the road. Alright, so there's our point. Just kind of tinning that guy up, and what I'll do is just run this right over to it and install that bad boy. So now we got a nice little point installed there. See, it's got a nice little ball of solder, and once again, back from the point a little bit, just a small little glob of some hot glue, just to support that thing in case we accidentally tug on it. Give it some strength. Alright, so those are the 2 points. Technically that is the alternate standby click on the Trinity consoles. Again, I showed you that one that you could use on the top if you were really gung-ho for it. And then so the next point that we're going to do is going to be point E. Remember, D and F are left blank here, and that one's actually really easy to find. If you look for this capacitor up towards the front, there's this little bitty point, Racha DB2G3. So let's let that focus in. DB2G3. So no significant amount of effort required here. It's a pretty easy point to grab. I'm just checking my length here. Go ahead and pre-tin it a little bit. I'm doing this without putting flux down again because I'm using some rosin core, so it has a little bit of flux in it, and I have done this a bunch of times. So my advice to newbies or first timers would still be to use flux even on points like that. And then yet again, with the hot glue, I like to just back it off just a little bit and give myself a little anchor, a little dab of glue, so that if it gets yanked on, it'll be okay. So the point's on there nice, no problems. And we just connect that over to position E. So here's the other end of my wire going into E. Alright. Now, we are back at the point where we can do our RST wire install. And again, I saved this one for last because it does have the potential to be fairly difficult. There are alternate RST locations on the underside of the board. However, I have found that they do not function quite as well. They do not provide quite as good of a booting experience. So the preference would be to use this point. However, if you found it acceptable to use or you were extremely intimidated by the size of that resistor and didn't want to do it, the point that you could use, I'm just going to highlight it real fast, is on the underside of the motherboard, and it's this FT4R2 point. So right here near the X clamp, we have FT4R2 right there. So that guy could potentially be used as an alternate point, but again, I do not believe that it provides quite as good of an experience. You know, maybe we should try it, and I should switch it out afterwards as a test case here. Let's do it. Let's see what happens. So I'll go ahead and hit that with a tiny bit of solder, and then I'm gonna go ahead and pre-tin my point there. Give it a little bit of a solder bath so that it's ready, and then we'll just come in with our wire and get it right on there, no problem. Once again, I'm just going to use my little cotton pad, clean up that flux, and yep, once again, also going to hit it with a tiny bit of hot glue, which I guess I'll have to demonstrate how to remove, just to add some strength to the point again if it was to ever be tugged on. So just giving it a second for the glue to have a moment. We'll pass through the red wire. So red wire passed through, and then I am going to just keep the same principle of trimming things up. So there goes to A. And this is part of where, you know, having the hot glue on there makes me feel better about stripping that wire while it's connected to the board, while I'm pulling on it a little bit. Because if I slipped and I tugged on it a little too hard or something, that glue is going to take the force rather than the point on the motherboard. So there's our A, our ST point. So we've used alternate points on here specifically so that they're a little bit first time soldering dude friendly. Now the next point that we're going to do is actually just program the glitch chip. So with our programming cable, we've got a little bit of pin header that's just been inserted inside of it to make it so that we can make connection with the pins on the chip and be real easy. They're labeled here, they're labeled on the chip, so it's pretty bulletproof to mess up. So we'll go ahead and connect our programmer cable, which is just reinforced with a little bit of hot glue here because these are all really fragile. And we're going to hold that on the glitch chip so we get a little power indicator here. I'm holding a little bit of pressure this direction just so that it makes good contact here, and then we're going to pop back over to our JRunner install. We're going to go to Advanced, Custom NAND CR Functions, and then XSVF, and then we're going to load up the timing file. So I keep a copy of the timing file that we want right here, Muffin-71, but I will post the small little package of Muffin files. There are a series of them here. So if we go Muffin, Trinity, we're using the 48 megahertz, the onboard clock. So there are all of these files. I just keep a copy of that 7.1 in my main directory. So I will, I'll provide that in a link in the description as well. And then we just say run, and then you can see that the output size says done here. I'm going to do it a second time just with the chip so that visible, so you can see what happens when I click run is the chip lights up, and then right as it finishes the light goes away. So again, run, and then we get the done message and it goes away. So we just programmed that chip 3 times. It's fine. It doesn't matter if you kind of reprogram them. It's not an issue at all. So we are now ready to go ahead and place our console back into its housing, because we shouldn't need access to the rear of the console anymore. We can go ahead and reattach our ring of light board, and then The next step is to write the ECC file, right, to the console. So we read the NAND initially, but that was before we had the glitch chip in. So now the ECC file is what will allow Zell to boot. So we'll take our NANDX, we'll connect that to the NAND wires here, and then we will apply standby power. So again, we're not turning the console on. And then we'll go back to JRunner here. I'm going to move this over to the side. We're going to make sure that glitch 2 and CR4 are selected. We're going to say create ECC. Then we're going to say write ECC. And we should see that takes just 50 blocks. So it happens really nice and fast. And our ECC file is now written to the console. So now we can come back to the console. We can unplug our NANDX. What I like to do is unplug power and then replug power, because now we're actually going to go ahead and try to boot her up. So grab an HDMI here, and then because I like to be lazy and not type the CPU key, I'm also grabbing an Ethernet cable, and I'm going to plug that guy in. So now when we attempt to boot the console here, I'm going to turn it on using my infrared remote. You could attach the faceplate cable to that. You could use a little metal object and short the pins here. You could use a synced controller that you have. For me, the infrared remote just works pretty easy. So go ahead and press the power button, and you can see we get a blinking light indicated here, and hopefully within a cycle or two here, we will get a successful boot on the console. Alright, so pretty quickly we got a nice boot here as indicated by the ring of light, and we can pull up the Xbox screen and see that we are getting Zell. So Zell is happening for us. That's great. That's exactly what we want to see here. At the bottom of Zell's output here, we've got our CPU key. We could manually type that into the blank over here in JRunner. You could copy that down, take a picture of it, and then type it in. However, because I'm lazy and I connected an Ethernet cable, I can see a network config 192.168.1.206. So what I can do is come down here to my IP, enter my .206, and click Get CPU Key, and it just sucks it across the network for me rather than me having to manually type it. So now that I've got my CPU key, I can go ahead and actually turn my console off. So I just powered it off. I like to go ahead and disconnect power while I'm sitting here, and then I'm not going to need my Ethernet cable anymore, so I'm just getting rid of that guy. Now that we have the CPU key, we can build our final XE build image. So we want to make sure glitch 2 is still selected, CR4 is still selected. We've got our CPU key. We can go ahead and create XE build image. So we're going to create XE build image here. It's going to spit out a nice blob of text status, and at the end of the day we have a updflash.bin, an updated NAND image that is a glitched image here for our Trinity console. So what we want to do now is once again plug in our programmer, and then reattach our standby power. So again, we're not powering it on, just standby power. And then we're going to go back to JRunner and finally click Write NAND. So now you can see we're writing the updflash.bin, and that's going to take about 3 minutes, I think. It goes all the way to 3FF in hex. So we'll give that just a few moments while that finishes up. All right, so we've got completed writing our NAND dump or our UPD flash.bin in 1 minute and 53 seconds. So we can now go ahead and disconnect our NANDX. What I like to do is unplug standby power for just a second and then plug her back in. And then now I've still got my HDMI connected. We're going to use the remote and we're going to boot it one more time. And what that should do for us is show us that the console will boot into a standard XE build dashboard. So nice quick boot time there. It is still a CR4 speed up type technique. The Xbox is going to boot into a normal appearing type looking dashboard here. And if you'd like to see some sort of verification that this is modded, what I can do here is I'm going to go ahead and put my controller in syncing mode, press the little button, so I'm syncing my controller, and we'll go back. I'm going to show you that under the Games tab, we've got just a couple of demo game things here, nothing worthwhile. I'll plug in my USB that has a copy of XEX menu already loaded up on it. I will go back to the Xbox here, and when I go into the Games tab, you can see the two original, but as soon as that USB reads in, we're going to get XEX menu show up for us. So there's XEX menu. And okay, so it has not had the avatar update applied, and I store that on the same USB, so I'm going to go ahead and let it do the avatar update. That is the $$ system update that you can get from Xbox.com. There are a number of articles available online for how to apply the avatar update to your console. It's one of the things I take care of up front for my customers, so this particular step could kind of be skipped for right now, but that's what's happening at the moment, is it's applying the avatar update, because we're already on dashboard 17511. So once it applies this avatar update, it will reboot, and we'll get a chance to watch it booting in here. So you can see that the top left indicator stays on, but the chip is in fact blinking again, so it is attempting to reboot here already. So once it successfully reboots, I'll be able to demonstrate that XEX menu is in fact functional on the console. There we go. So there's our reboot. We'll see that here momentarily. Go back to the Xbox screen. It's restarting. So now our avatar update is installed, and you'll notice that my my TWM account there has the avatar visible on it, which kind of proves point in case that the avatar update is in fact installed. So if we go to the Games tab, because that USB is still in here, we have XEX menu, which I can go ahead and launch, and thus kind of proving that I am in fact a modded console. So what would I do from here? I would maybe reassemble the console, put a hard drive in it, copy over Aurora, dash launch Freestyle onto the hard drive, set up a default boot within dash launch. So if you want it to boot up, you know, some sort of application automatically, like XEX menu or a modified dashboard, you can definitely do that. You can see in the lower right there that we are a glitch 2. So this is a CR4 speed up Muffin install, which is still uses RGH2, but you do want to make sure that CR4 tick box is selected. We can also see in the system info, you know, we've got normal spam stuff. You can see your CPU key. So la-di-da, we have a modded console, and we have used that CR4 Muffin technique to pretty good effect. What I'd like to do real fast is just a couple of boots to see how the timing is using that alternate RST point from the underside. That one is going to be a lot less dangerous than soldering to the top of that resistor, So I think a lot of people might choose to do that if this performance is still good. This is actually only the third Muffin install that I've done, but I wanted to share this information because the latest batch of Ace V3 chips that I've gotten have been pretty shitty for Trinities, to the point of not working. So this install is an alternative to that with a less expensive chip, and I'd like to kind of have a benchmark for how the boot times are. So we'll try it again here. I just fired it up. So that was essentially a first glitch instant boot. That was really nice. Let's power that bad boy off. And what I generally just do is just wait for the fan to stop spinning. That's kind of my indicator. So I powered it off. There it goes, shutting down. Come on. I could yank the power, but that's not ideal either. Okay, so fan just shut down. So that was one instant boot. Let's try another. Okay, so that was a cycle with no boot. So one. That looked like another cycle. Two. So that was on the third cycle with that one booted. So that's still sub 30 seconds all day long. I mean, there's our boot. It's coming up just fine on the screen. So let's power off again. Let's do 5. We'll make that my goal here. We'll do 5 boots. So that was 2. So the first one was 1. I feel like I should write this down. The second one was 3 cycles, which is still nice and fast. Alright, so there's it cutting off again. There's the fan stopped. Alright, let's try another one. Oh, there's another instant. So we got 1, 3, 1. Nice and fast. So just power it off real quick while it's still coming on. Alright, so we've had 1, 3, 1. There's it stopped again. Let's try another. Boop. Okay, so there's one cycle missed. Looks like you got that on the second cycle there. So we got 1, 3, 1, 2 on the fourth boot attempt. So far 3 boot cycles is the longest we've had it take. Powering off again. Alright, come on guys. Alright, so there's it shutting down, fan going off. We'll try that 5th boot. Let's see how this goes. So there's 1 cycle it looks like. That looked like a 2nd cycle just about. I don't know whether to call that the 3rd. I think that was probably the third, maybe 4th. Still under 30 seconds. So we got 1, 3, 1, 2, 3 as far as boot counts go. It's booted up really nice and consistently. I think if anybody was using this console and needed to reboot frequently and stuff, they'd be certainly very happy with the performance. I think I'm actually going to withdraw my suggestion that you ever use the little resistor point up here, given how many people I've seen just ruin consoles over it. So we're talking a wiring install just like I did, using all the alternate safe points on a $5 glitch chip with a $30 programmer for like 40 bucks. You can have your Trinity glitched with this sort of really nice performance here. I hope the tutorial was helpful. please feel free to check out store.weekendmodder.com. I do make a couple of bucks off of reselling some of these products. If you felt like my tutorial has been helpful and you'd like to support me a little bit, I'll be the first to admit my prices are just a little bit higher than like the cheap eBay China stuff. The good news is that if it's in stock on my website, you are going to get it in about 3 or 4 days because it does ship from inside the USA. So yeah, thank you very much for watching, and I hope everybody enjoys. Thanks.